Hi, my name is Muhammad Arif Ahmad Bijrami. My matrix number 01DDT20F2027. Today I will talk about introduction of minimal spanning tree. Minimal spanning tree is a spanning tree which has minimum total cost and has smallest possible sum of weight of the edges. If you have a linked undirected graph with a weight or cost combined with each edge, then the cost of spanning tree would be the sum of the cost its edges. Okay, we have decided to use the Kruskal algorithm in our case study. Kruskal's algorithm is used to find the minimum spanning tree for a connected weighted graph. The main target of the algorithm is to find the subset of edges by using which we can traverse every vertex of the graph. So for our question, I will pass it to Nurul Natasha. Thank you.
Okay, thank you Arif Aiman for the explanation. Now I will continue this presentation by explaining how I and my team solve our case study question. The map that we chosen for our case study presentation is Welcome to Melbourne Map. So on behalf from my team, in this presentation, I will show how we solve the question of our case study. We decided to use Kruskal algorithm for the technique that we will apply when we solve this question. So let's get started. Okay, the first step is we have to find the smallest weight of each. So in this map, the first smallest edge is from the Yarra Park to the Olympic Park. As you can see here, from the Yarra Park to Olympic Park, which is 1.0. The weight is 1.0. So we have to underline it. From the Yarra Park to the Olympic Park. So this is our first edges. Okay. Next, the second smallest number is 1.2, which is from the Olympic Park to the city center. So this is our second edges. I will underline it from the Olympic Park to the city center, 1.2. So this is our second edges. Next, our third edges is from the Yarra Park to the Royal Botanical Gardens, which is 1.4. From the Yarra Park to the Royal Botanical Gardens, our third smallest edges, which is 1.4. So we will underline it too. Yarra Park to the Royal Botanical Gardens. So this is our third edges. Okay. Move to the next one. So in the next one is 1.5. As you can see here on this map, we have two same numbers of way, which is from the city center to the Flagstaff Garden, 1.5. Also from the Yarra Park to the city center, 1.5 also. But we can't choose, in this case, we can't choose from the Yarra Park to the city center because it will produce loops and it will block the way. And then, in this case, I will choose from the city center to the Flagstaff Gardens for our fourth edges, which is 1.5. The next one is 1.6 from the King's Domain to the Royal Exhibition Buildings. So I will underline it. So our fifth edges is from the King's Domain to the Royal Exhibition Buildings, which is 1.6. The next one is 1.7, which is from the Royal Exhibition Buildings to the Fitzroy Gardens, which is this is our seventh edges. So from the Royal Exhibition to the Fitzroy Gardens. So this is our 6 edges, and this is our 7 edges. Okay, move to the next one is 1.8, which is from the Flagstaff Gardens to the King Domain. So I will highlight it. So Flagstaff Gardens to the King's Domain. So this is our 8.8 edges. Sorry, let me count it back. Sorry, so this is not the 8, not 7, this is not 6, 9. This is our 5th edges, this is the 6th one, and this is the 7 edges, and move to the next one, which is 2 point. As you can see, the next one is 2.2. We have two same numbers. In this case, if we have two same numbers like this, we can choose it randomly. You can choose whenever the way you want, but in this case, I will choose the first one. I will choose from the Royal Exhibition. This is here from the Royal Exhibition to the Melbourne Museum, and this is our 8 edges. Okay, and the last one, and finally the last one, I will pick from the Melbourne Museum to the Government House, which is this is also 2.2. Okay, so this is our last one, which is this is the 9 edges. So I already finished drawing the map. As you can see here, this is how the map when after I highlight it. So let's we proceed to the real to my drawing. I will drawing back this map to make it more clear and easy for us to calculate the total of weight. Okay, so let's move to the next slide. Okay, so this is the result after I draw back the diagram. The total of the edges here, as you can see, let's count together. This first one is 1.0, which is from the Yara Park to the Olympic Park. The first one, the second one, third one, fourth, fifth, 6, 7, 8, and last one is 9 from the museum Melbourne to the Government House, which is so here the total of the edge here is 9. We have 9 edges. So to calculate the total of weight, I will pass to my next team to my team member. So to calculate the total of weight, I will pass to Hazim for continue this presentation. That's all from me. Thank you.
Natasha. Next, I will explain about how to calculate the Kaskel algorithm table for the Melbourne maps. So, the first of all, in the Kaskel table, we need to sort the age weight from the nearest kilometer to the farthest kilometer. So, as we can see here, the first ages we put is Yara Park to Olympic Park, and the weight is 1.0 kilometer, and number 2 is Olympic Park to Center City, and the weight is 1.2 kilometer, And the number 3 is Sierra Park to Royal Botanical Garden, and the weight is 1.4 kilometer. And the number 4 is Center City to Flagstaff Garden, is 1.5 kilometer. And number 5 is King's Domain to Royal Exhibition, is 1.6 kilometer. And number 6 is Royal Exhibition to Fitzroy Garden, and the weight is 1.7 kilometer. And number 7 is Flagstaff Gardens to King's Domain, is 1.8 kilometer. And number 8 is Royal Exhibition to Melbourne Museum, is 2.2 kilometer. And the last one is the Melbourne Museum to the Government House, is 2.2 kilometer. And so from all this weight, and we get the total weight is 14.6 kilometer. So that's how we calculate the classical algorithm for the table Melbourne maps. We need to start with the nearest kilometer to the farthest kilometer. So that's all from our group. Thank you for watching.